So we are starting the second lecture of Fundamentals of Soil Science course. In this part we will talk about rocks. So rocks may be defined as a hard mass of mineral matter comprising two or more rock forming minerals. Mainly rock consists two or more than two types of minerals, and they formed like a hard mass and that present on the earth surface or maybe inside the earth surface. So earth crust, the total earth crust comprises two type of rocks, that is igneous rocks and another one is sedimentary rocks. Igneous rocks comprises about 95% of the total earth crust and other 5% is comprised by sedimentary rocks. But things changed when we see only the upper 5 kilometer of earth crust. Then the igneous rocks consist about only 18% and sedimentary rocks about 74%. And there are also other type of rocks like metamorphic rocks. They can contain about 8% of the earth crust. After that we have the formation of the rocks. So in this portion we have three things, that is cooling and concentration of magma, transportation and sedimentation of fragmentary material, alteration of pre-existing rocks. So in these three things mainly describe about three types of rock. One is igneous rocks, another one is sedimentary rocks, and last one is metamorphic rocks. If rocks are formed by cooling and consolidation of molten magma within or on the surface of the earth, they are called as igneous or primary rocks. Let's see in picture. If it is our earth upper surface, then we live on this area. Here we live. This is a stick man, I guess. So the rock may be present on this area, on the upper surface, or maybe in the lower region of earth crust. So that are the types of igneous rocks. So after that we have the transportation and cementation of fragmentary materials. Mainly the igneous or primary type of rocks can also be disintegrated and decomposed. Then the breaking down of that type of rocks will be transported in a solution by natural agencies like air, wind. So they will form another type of rocks. They are called as sedimentary or secondary rocks. So first of all was primary rocks, then by breaking and transportation the second type of rocks or secondary rocks are formed. After that alteration of pre-existing rocks occurs, and then third type of rock occurs. They are metamorphic rocks. The primary and secondary rocks, when subjected to earth movement by high temperature or pressure, they are partially or wholly altered into new rocks. They are changed into new rocks. So there is a metamorphosis happening. By that, rocks are changed into another type of rocks. They are called as metamorphic rocks. So after that we have the brief definition of igneous rocks. Mainly they are characterized by non-laminar massive structure. Non-laminar means they have no particular columnar structure like any other type of rocks. So the whole make up about 95% of the earth crust. As I said before, that description was given in previous part also. After that, the source of parent material for other rocks is igneous rock, because if we see the sedimentary rocks, they are created by breaking down of igneous rocks. Also they are the source of metamorphic rocks too. So igneous rocks can be classified based on the mode of origin and chemical composition. Let's see that. Based on mode of origin, they are classified as extrusive or volcanic rocks and intrusive or plutonic rocks. If we see the volcano, then volcano just throw out the magma and then by that magma some type of rocks are formed. So they are formed on the surface of the earth, so they are called as volcanic rocks. And another type of rocks are plutonic rocks. They are formed within the earth crust. Cooling of magma is very slow there, and the crystallization also takes longer period of time. Fine size crystals are formed in the volcanic rocks portion, but coarse crystals are formed in plutonic rocks. Mineral grains can be observed only under a microscopic or magnifying lenses, but here the mineral grains can be seen with naked eyes. Rocks have glassy structure. This is look like glass. You can see from this side to the other side. So examples are basalt, andesite, and rocks have hard and massive structure. They are very big, and also their weight will be also more than volcanic rocks. So the examples are granite and syenite. After that we have these are also called as extrusive rocks because they are formed outside of the earth surface, mainly on the upper region of the earth crust. So they are called as extrusive rocks. And also the plutonic rocks are called as intrusive rocks because they are formed within the earth crust. So then we have, based on the relative amount of acid and basic components, classified into two types. That is, acid component is called as silic acid or silica, and basic components are present in the rocks are soda, potash, aluminium, lime, manganese, and iron oxides. So acid rocks are consist about 65% silica. Examples are granite. Then sub-acid rocks, they consist about 60 to 65% silica. Example is syenite. And then we have sub-basic rocks, 55 to 60% silica. Examples are diorite and andesite. Then basic rocks are there. They contains 45 to 55% silica. So examples gabbros and basalt. Ultra basic rocks, they consist less than 45%. So examples are dunite and lamproite. Okay. So mainly this composition of igneous rocks. So there is basalt and also there is granite. So basalt is the most abundantly formed rock from the molten material. It is fine-grained and dark-colored rock which contains 50% feldspar and 50% ferromagnesium minerals, including pyroxene and olivine. So mainly there are minerals like pyroxene and olivine too. The coarse-grained rock with comparable composition is gabbro. Here you can see that coarse-grained rock is also maybe present within the basalt. They are known as gabbro. So this basalt, 50% feldspar, 50% ferromagnesium. They consist pyroxene, olivine, but also the coarse-grained rock with comparable composition, they can be also present, and they are called as gabbro. After that we have granite. Granite, this is coarse textured and light colored rock that contains 60 to 70% feldspar, of which orthoclase is 40 to 45%, plagioclase is 20 to 25%, and ferromagnesian minerals are 3 to 10%, and quartz is about 20 to 30%. So mainly if we see this thing, then if it is a rock, just like don't go into the picture, then this part, it is comprised by another remaining factors than feldspar. If this part, this 60 to 70% part is comprised by feldspar only, in which we have orthoclase, plagioclase, ferromagnesium minerals, and quartz. So the fine-grained rock with above composition is rhyolite. So after that we have sedimentary rocks. Sedimentary rocks are formed from the sediments that derived from breaking down of pre-existing rocks, mainly the igneous rocks. The sediments are transported to new places and by some natural agencies like air, wind, and they are deposited and in a new arrangement and cemented there to form a type of rocks. They are called as secondary rocks. So these rocks are also called stratified rocks or aqueous rocks. Aqueous means maybe it is transported by water. So that's why they are called as aqueous rocks. And stratified means they are condensed or cemented from one place to another. After that we have formation of the secondary rocks. 4 stages are recognized in the formation of the secondary rocks. First one is weathering, second one is transportation, then we have deposition, lastly diagenesis. So weathering, the igneous rocks, mainly the primary rocks, disintegrate owing by physical, chemical or biological weathering. There are 3 types of weathering, that are this: physical, chemical and biological. And after that they provide basic materials for the formation of the sedimentary or secondary rocks. So transportation occurs after the weathering. These disintegrated part or materials are transported by some agencies, maybe by water, wind, glacier, or runoff water, or by gravity. So transportation is a function of speed of water, means the speed of water also depends in the transportation. After that, in the third step, deposition or sedimentation occur. So deposition means the detrital materials comprising minerals and rock fragments are deposited when the carrying agent has no longer energy enough to move it further. Mainly the water has transported from the place of origin to 1 kilometer away. So after that water force is not that much. So they are now condensed there or cemented there to form secondary rocks. So coarser particles settle first because they are mainly heavy type. After that the finer particles came over the coarser particles, and this deposition is called as graded bedding. You may get question from this thing that what is graded bedding. It is just the deposition or sedimentation when the natural agencies don't have any energy to move the particles further. After that we have diagenesis. In diagenesis, mainly the transformation of unconsolidated sediments to hard rock. The materials that are transported, then they are just deposited on one place, then they are condensed. Mainly the cementing step occurs in this diagenesis. So mainly it involves the compaction and cementation. After that we have the classification of the sedimentary rocks. Mainly based on origin, sedimentary rocks can be classified in different groups: residual, mechanical or detrital, inorganic or chemically formed. So after that we have the metamorphic rocks. So in this thing, residual, when the products of weathering settle at the place where they have been formed, they form into hard mass and they are known as residual. Residuals means what? That if any rock, if you see this is a rock, then this portion is broken down and this portion will be present on that place after breaking. Then the rock that will be formed on that area will be called as residual rocks. Example is bauxite. After that we have mechanical or detrital. Weathered fragments are transported, deposited in beds of varying thickness and cemented. Mainly, they can be transported from one place to another place by some agents. Example like sandstone. So they can be transported by wind when they are just the particles of the primary rocks. Also, there are shale and conglomerate. After that, we have inorganic or chemically formed. These are formed by evaporation or precipitation of the material in a sea or lake. If there is a lake where there are many minerals present in that place, but with increasing in the temperature, mainly the evaporation occurs. Then the minerals will form just like rock. They will be cemented there. So by evaporation, the rocks that are created like halite, that is called as rock salt, and also there is gypsum. And by precipitation, mainly sea just throw away the things that comes into it, will come within the contact of it. So maybe sea can transport any type of rock particles, and they are deposited in one place. So by precipitation and flocculation, some type of rocks can be created. The examples are limestone and dolomite. After that, lastly, we have the metamorphic rocks. The word metamorphic means change in form. Mainly, the form of the rock is changed from the igneous and sedimentary rocks. These metamorphic rocks are created. What is metamorphosis? Metamorphosis is used as a general term for all those changes that alter more or less completely the original character of the rocks. Mainly, it is the changing of the rocks from the original mainly. Then the formation. Igneous and sedimentary rocks are subjected to tremendous pressure and high temperature, succumb to metamorphism. Mainly by the pressure and high temperature, these type of rocks, mainly igneous and sedimentary rocks, change into metamorphic rocks. The changes in the deeply buried rocks are brought about by the combined action of chemically active fluids and internal heat and pressure. Just remember the things. The structure and the mineralogical composition of the metamorphic rocks depend on the composition of the original rock and the kind of metamorphism. Mainly, if any rock is silica in lot of amount, then after metamorphosis, they may contain also the silica in very good amount, because the original rock has that characteristics. So there are certain minerals such as tremolite, garnet, talc, mica and chlorite, which are the characteristics of metamorphic rocks. Mainly this type of minerals will be present in metamorphic rocks generally. The banded or laminated character is the most peculiar feature of the metamorphic rocks. Mainly, they will be present in some type of spatial structure, not like just igneous rocks. They are not non-laminated. But here, if you see the metamorphic rocks, they are laminated and arranged properly. Changes brought about by chemically activated waters, then that metamorphism is called as hydrometamorphism. Example, sandstone to quartzite, granite or basalt to laterite. After that, if the changes brought by heat, then the metamorphism will call be as thermometamorphism. Example like limestone to crystalline marble. And if the changes brought about by pressure, then it will be called as dynamo metamorphism. Example is granite to granite gneiss. That is not gneiss, it is gneiss. G is silent here. It is partial foliation process by which granite changes into it. Also, gneiss can be changed into schist. So that is complete foliation and shale to slate. And also there could be heat and pressure in both. They could be occur as both. Then the metamorphism will be called as dynamo thermal metamorphism. Example is crystalline gneisses, schist, and marble. They are formed by this metamorphism process. After that, we have classification of the metamorphosis. Based on the texture and the structure of minerals, the metamorphic rocks are classified into three groups. First one is foliated, second is unfoliated, and lastly there is granular. So based on the texture and structure of the minerals, first one is foliated. They have parallel structure. They look like leafed or leafy. These rocks contain micas and ferromanganesian minerals. So foliation, as the minerals are flattened and arranged in parallel layers. That's why they have parallel structure. And you have to just remember the minerals that are micas and ferromagnesium. They show foliation. So examples, you can just remember one or two. There's gneiss, and you can just remember slate. That will be easy for you. After that, we have unfoliated. That is massive. That they have massive structure. These rocks contain quartz and feldspar and do not show foliation. The previous one, that foliated one, shows foliation, but here in unfoliated they does not show foliation even under pressure because of the large size crystals. They are that's why here in bracket is written is massive structure. Examples are talc schist and graphite and amphibolite also. And in granular type of metamorphic rocks, they consist mostly the equidimensional grains.